Good afternoon and welcome to this webinar, How to Leverage Piping Systems to Increase Building Sustainability. This event, brought to you by Plumbing and Mechanical Engineer, is sponsored by Corzan. I'm your moderator, John McNally, editor of Plumbing and Mechanical Engineer, and thank you for joining us. Today's presenters are Tom Antenweiler and Terry V. Thiel. Tom Antenweiler is the product engineer at Lubrizol. He provides technical support to sales and marketing, as well as conducting business development for Lubrizol's engineered materials platform. As part of his current role, Tom monitors sustainable building practices. He has helped craft LEED pilot credits within the material and resource category under LEED version 4, and spoke at the Greenbuild 2017 International Summit on the topic of evaluating buildings and innovative materials in pursuit of sustainable design. Terry Thiel is the Director of Sustainable Product Strategies at Lubrizol. He has been with the company for more than 17 years, during which time Terry's principal responsibilities have included strategic planning support and legislative and regulatory advocacy with an emphasis on environmental matters. In particular, Terry has led Lubrizol's growing involvement within environmental life cycle assessments. Don't forget to submit your questions, and later in the program, our presenters will address as many as possible. Today's event is being recorded and archived on webinars.pmengineer.com. And now I'm excited to turn it over to today's presenters, Tom Antenweiler and Terry Thiel.
Thanks, John. Quick overview of our agenda. So we're going to start out by talking about the changing face of sustainability. You know, over the past few decades, as we've learned more and more about people and their interactions with materials, that category has broadened quite a bit. So Terry's going to talk to you a little bit about that. The next topic, we're going to dive into what a life cycle assessment actually is. There have been, in recent years, a lot of guidance given on how to properly carry out a life cycle assessment, and Terry, again, will help walk you through that. And then finally, we're going to talk about what all this means in relationship to the building industry. You know, there's a constant turnover in building stock, and life cycle assessments can really help us prioritize how we use our resources to produce this building stock and also optimize those buildings' utility. So to kick us off, we're going to start with a polling question. If you all could just answer yes or no to this question. We want to figure out how many of you have previously used a product life cycle assessment in your work. If you are aware of them, have used them for comparative studies, have just been curious and gone to look for them, we really want to gauge the audience and see what your familiarity with life cycle assessments are.
And hopefully, depending upon the degree to which the audience has some familiarity, I'll gauge my comments accordingly. The last thing you want to do is being told what you already know. But it looks, as the numbers are coming out, that a majority of the audience hasn't had any experience with the life cycle assessment process. So I will ask the forbearance of those of you who have had some experience to bear with us as we go through the process of explaining it in a little more detail for those who haven't worked with it before.
So it looks like we're leveling out here, so I'll go ahead and close the poll. Looks like we're at about 40-60.
Okay.
All right, Terry, you ready to launch into this?
Take it away. The first thing you need to know about life cycle assessment is context. And if we take a bit of history here, the environmental emphasis on manufacturing and processes really has only emerged since the end of the Second World War. And during that, what I'll call the first phase of environmental awareness, the major focus was on what I'll call smokestacks and drain pipes. It was all about manufacturing. It was about the emissions coming out and the waste being generated. We're here in Cleveland, and we have some notoriety here in Cleveland for having the Cuyahoga River, which on numerous occasions caught fire during the 50s and the 60s. And if we can advance the slide to number 8 there. let's see if, there we go. What's really happened since that early phase is growing sophistication in the analysis and a growing awareness that there's more to environmental impact than simply what happens inside the gates of a manufacturing facility. So to look at the true life cycle of a product means going upstream to raw material extraction, through the transportation of the materials, the manufacturing of the materials, down through the finished product manufacture, again, including transportation whenever, the actual use or consumption, and the end of life as well. And taking the totality of all of those impacts is what life cycle assessment is all about. What you're seeing here is sort of a visualization of that analytical process, where every step in that process there are inputs and outputs. Usually the inputs are raw materials and energy, the outputs are waste streams, be they either solid, air, or water. And by tallying them all up over the life cycle, that's when you get the total benefit or impact, I should say, of a given product. There does seem to be, though, at the present time, a fair amount of confusion when we start talking about terminology around life cycle assessments. You will frequently see businesses talking about emissions, energy, waste, and these are all what I would characterize as inputs to the analysis. They are the source of the environmental analysis that takes place. What comes out of that analysis are what I'll call the impacts. And here there's part of this is what drives me slightly crazy is everybody wants to be green. Well, there is no definition of green. Green is not one thing. When you talk about environmental impacts, you are talking about a basket of different impacts, be it acidification, which is an air emissions issue, the deposition of acids from air emissions on forests or on farmland or in urban areas. Climate change, which is probably the most well-known. Eutrophication, which is about basically the runoff of fertilizer type materials into freshwater bodies that lead to oxygen deprivation, and basically you'll see algae blooms that kill off all aquatic life. Then you have forms of ecotoxicity, human, aquatic, marine ecotoxicity. Toxicity is a very confusing term when we talk about life cycle assessment, because people will normally associate that with what traditional regulatory requirements look at. Traditional regulatory toxicity is about an endpoint. It's about a direct potential threat to human health at a given place and a given time. Ecotoxicity in the context of a life cycle is tallying up the toxicity loading across the life cycle for a given product. So the toxicity burden associated with raw material extraction, of manufacturing, of transportation, of product use, and of end of life are all tallied together to give a toxicity profile that does not necessarily represent a direct threat to human health at any given place or point. So it's unfortunate we use the same word toxicity. It means something different in the context of life cycle. Human health and safety is a variant on that, and here we are talking directly about the threat posed by, let's say, air emissions, formaldehyde, let's say, as an example, that might pose a direct human risk at a single point in place. The term natural capital is basically talking about our basic resources, our non-renewable resources and their consumption. photochemical smog formation, NOx and ozone emissions that combine with sunlight and give us smog, for which LA is famous. Resource depletion, actually, between natural capital and resource depletion, there's a bit of an overlap. One has to do with non-renewable resources. The other has to do with renewable resources. Think of it this way. You don't want to fish all the fish out of the ocean. You don't want to cut down all of the trees in the forest. You don't want to deplete that particular part of the biosphere's resource chest. Societal welfare is obviously a critical element here. The ability to allocate and use our finite resources in a fair and just manner so that all populations in the world have fair access to the benefits. Stratospheric ozone depletion, which is controlled by the Montreal Protocol, and terrestrial toxicity, loading of again, the toxic elements that I mentioned earlier into the soil. The challenge with looking at the impacts is that every single one of these in a life cycle assessment has a different unit of measure. And so when you are trying to compare them, it is extremely difficult. How much toxicity is worth how much climate change? The life cycle assessment doesn't answer those questions. What the life cycle assessment does is it gives you better data to address them, but you still have those challenges ahead of you. If you were to take the life cycle impacts, well, what can you do with them? Well, I think first, you can use them to identify burden shifting. In some cases, you may change your manufacturing process in order to reduce your VOC emissions, let's say. But in that process, you wind up increasing the burden at end of life because you've made the final product more hazardous. So the point is understanding that you can't necessarily guarantee that any improvement you make is not going to have a negative consequence. And those trade-offs, life cycle assessments help you identify. You can either shift impacts along the value chain, that is, I reduce my manufacturing and I increase my useful life, or I make a shift among impacts. I reduce my toxicity, but I increase my climate change. Or the other, the final bullet here, which is basically I'm no longer doing it. I've pushed it upstream to my supplier or overseas, understanding that it doesn't go away. It's still part of your life cycle, even if it's not within your gate anymore. The other opportunities that life cycle assessment provide are identifying basically trends. To the extent that you look at life cycle analysis over time, you can see a shift from one impact to another, an increase or a decrease. It looks at basically orders of magnitude. Any life cycle assessment I look at, if there's a decimal point, I'm suspicious. The number of assumptions that go into an LCA analysis are such that it's basically safe for orders of magnitude change, but no more. And it also allows you to enable comparisons among different products. And this is part of the challenge, either looking at different products or an older version versus a newer product. You'll frequently see in the contemporary literature a lot of third parties who are giving their opinion as to the environmental utility or threat posed by a given product or a given formulation. But all too often, those analyses don't necessarily tell you, okay, I can't do this. Well, what can I do? They don't give you that comparative analysis. LCAs give you that basis for analysis. What we're showing you now are a couple examples of the sort of work that we have done looking at CPVC piping. And I'm going to turn this back over to Tom now to give you a more detailed understanding of what Lubrizol actually has been doing.
Thanks, Terry. So as Terry outlined, LCAs offer a very comprehensive assessment of impacts, and they can be used to optimize the resources needed to build and maintain our buildings. But with all this data, what do you do with it? How do you make comparisons? These LCAs can be over 100 pages of data, and that's quite a bit for any one person to sort through for every single building product in a building. You all know too well there are way too many building products in a single building to do that for every single one. So what the market, I think, is starting to do is they're looking for manufacturers and third parties to help them make those assessments. So at Lubrizol, we've put in a lot of effort and a lot of work to generate LCAs on our piping systems and to begin comparing the outputs to other options within that functional category, we'll say. You can see two examples here for plumbing pipe, CPVC and PEX outputs, and then also for fire sprinkler pipe, where we're looking at CPVC fire sprinkler pipe versus steel piping systems. You'll see the outputs that Terry talked about along the bottom. The vertical axis is a relative score, so I made sure to normalize it here, where you'll see the lower numbers are for less of an impact, the higher numbers are for more of an impact. So it's a relative rating here, and a lot of times when you're looking at comparisons, you really just want to look at the relative impacts, right? Unless you're trying to do, like Terry said, and shift burdens, and then you might be more interested in the exact numbers. And Terry, feel free to jump in.
Yeah, and understanding, of course, that just because the bars are the same length doesn't necessarily mean you can automatically equate one unit of impact to another unit of impact. Again, how much toxicity is worth how much climate change. When we do LCAs, I use sort of as a model. Think of it in 3 dimensions. How severe is the consequence? Does it give me a cold or does it kill me? How long does the impact last? Is it minutes or centuries? And geographically, how much does it cover? My living room or the globe? And those 3 parameters help you understand and look at the trade-offs among impacts, but there's no answer in the back of the book, unfortunately.
Right. But what you touched on is what this data will eventually help us do. It helps us to assess risk.
Yeah.
It's hazard times exposure gives you the final risk. You can't just look at hazard, you can't just look at exposure. And that's an important point that I want to move into when we're talking about some of these sustainability assessment tools, rating systems. I want to talk a little about LEED. I think most people are familiar with LEED and what it has done for the building industry. For those that aren't, it's Leadership in Energy and Environmental Design. It's administered by the U.S. Green Building Council, and it's really pretty widely accepted in the sustainable building realm. So I want to talk about how we can use life cycle assessments and the information from them within this context of LEED and what they're doing to help guide us in this realm. So we talked about life cycle assessments and how they really they're encouraging transparency. They don't give you a comparative analysis, and each output has its own individual unit of measure. So it's very much confined to comparing that output to the similar output of maybe a comparative material. So how is the recent LEED v4 version helping us to work through this? Well, like I said, it encourages transparency. So by simply having a product LCA, that can get you credits toward your LEED certification. And more piping systems and fixtures are showing this. And I'm going to walk through some other credits that you can also get from piping systems. But I want to point out there's a transition happening right now, I think, in how we view sustainability, as Terry laid out. The first step is gathering data. That's the transparency that's trying to be encouraged with LEED v4 and then also with the pilot credits that I have listed there. The first one is integrative analysis. The second is health and exposure, and the third is supply chain optimization. For integrative analysis and supply chain optimization, these really are truly transparency credits. So they're encouraging companies to perform life cycle assessments and to really dig into their depths and find where they could do better, and also share that information so that people can make educated decisions. The health and exposure is an interesting one because it takes some of that information that's available that companies have provided, and it'll actually do some exposure modeling, which is a new approach that we hope takes off here in the future. So please, I'll encourage you, I don't have time to go in depth into these pilot credits right now, but if you have questions, feel free to reach out to us or to the U.S. Green Building Council. We'll be happy to help you walk through those. I want to talk a little more in depth about the integrative analysis of building materials pilot credit. So this pilot credit was set up kind of like the outputs of an LCA that you saw. So you have various life cycle stages: product assembly, manufacture, the installation, the use, the maintenance of that product, and then what happens at the end of its life. And you have three impact categories: human health, occupant safety, and environmental impacts. The way that this credit's set up is that the building product manufacturer will take the information that's known to them, and this could be from an LCA, but it could also be from other sources. It could be from safety data sheets. It could be from some product listings, such as those through NSF or UL. It could be their own internal data, and they can fill out this matrix with statements addressing each of these impact categories within each of the life cycle stages. Now, those statements have to be backed up with documentation, but what it provides is a stepping stone for maybe companies or people who don't have the resources yet to put into an LCA, but do have a lot of information and knowledge about their product and want to get that out there into your hands so you can make educated decisions about what you're using. It can also show you between a couple different products, you know, what products, what companies are looking at these kind of things and really taking a deep look inside and trying to figure out where their shortcomings are. So that kind of thing can come out within this credit. And I think it's a useful credit in that path toward transparency and eventually comparative analysis. One other step that I didn't mention previously, which I wanted to, is talking a little bit about environmental product disclosures. You may have heard about them. They're in short form, they're called EPDs. They are a product that is born out of a life cycle assessment. The advantage of an EPD is instead of being over 100 pages, it's condensed into 5, 10 pages. What it allows for is products of a similar category to be compared. So it sets up the application, that'll be the category, and also the reference unit, or we're called functional unit, of material that's being compared. So for the sake of this presentation, let's talk about piping systems. You know, maybe you would set that functional unit at, say, 1,000 feet of pipe of a certain diameter, or maybe you would say it's a certain amount of material. Those categories are still being flushed out by third parties. They call them program operators. ASTM is one of them, to give an example. But as we work our way through this process and build these out, hopefully you will find that there are going to be more and more tools available to you to make it easier to make these decisions. I want to touch a little bit on occupant health. This, I think, is the one point within this whole realm of sustainability that piping systems can possibly have the greatest impact on, because we touch something that is being consumed by humans. A lot of people have heard of Legionella and may be familiar with ASHRAE 188. And there are two aspects of this standard. Really, the standard provides guidance for prevention and mitigation of microbial growth in piping systems. For prevention, I just want you to think about for a minute, how will a piping system material change over time? And how will this affect the harboring of bacteria? If you think about sustainability within a building, you really want your systems that you install to last the life of the building. Having to take out and repipe systems, that really affects the sustainability and the utility of your building and can introduce new hazards to the occupants. So the ideal is to install your mechanical systems into a building and not have to touch them for the life of the building. So think about the effects of water on your piping components and how it might create opportunities for bacteria to be harbored. We're talking about corrosion and pitting in piping, lack of flow in piping systems as well. These things really encourage the growth of bacteria. So when you're thinking about piping system materials, make sure you're thinking about the system that you're designing and the water that's going through it and how it's going to affect that piping material. The next part is mitigation. So ASHRAE 188 recommends decontamination temperatures around 170. So again, going back to thinking about a piping material, you want to consider materials that are going to be reliable when they're repeatedly exposed to chlorinated water at 170 F. That's the one way to ensure that your occupants will be safe in the near future from any kind of microbial growth. And don't limit your thought to just purely hot chlorinated water. You know, biological organisms are always changing, evolving, and if you're thinking about the life of a building being 30, 40, 50 years, you've got to take that into account. What other possible decontamination methods or chemicals could be used in the future? And you want to choose the right piping material that can withstand those forms of disinfection, or the broadest number of disinfection methods that you can think of now to set yourself up in the future. So when we're talking about sustainability of piping systems, it really encompasses how the material will respond to the application needs over the life of the building by avoiding damage to itself and also keeping its occupants healthy.
Tom, and if I could add on that point, the interface here between the occupational health issue and a life cycle assessment, the occupational health goes back to, if you recollect, I said about toxicity as a direct endpoint threat to human health. That's what this is about. So this would not necessarily show up in your LCA analysis. What would show up in the LCA analysis, as Tom pointed out, is if you have a piping system that does not last the life of the building, and because of this sort of deterioration might conceivably require replacement. And of course, all the associated environmental impact burdens with that replacement, if you're looking at the life cycle of the system over the life of the building, that's a huge impact there.
Mm-hmm. Thanks for making that point, Terry. That's an important one to take away. I want to continue on occupant health because I think it is an important topic for piping systems. A lot of you are probably familiar with NSF 61 and the Drinking Water System Components Health Effects Standards. This really feeds into the LEED heavy metal reduction credit that exists out there. And again, like I said, I'll summarize these at the end of the presentation. But your piping systems can help achieve those kind of credits just by simply being listed to these standards. It's a very important standard to understand, again, similar to ASHRAE 188, when you're thinking about how the water going into your building, what kind of ranges of pHs are going to be exposed to, how does that affect any kind of leaching out of components or materials in your piping system, and then what temperatures are going to be exposed to your piping system. The standard tests pHs based on the type of material. So copper is tested at 6.5. Other materials are tested at a range from 5 to 8 or 10 on the pH scale. Materials are also tested, all of them are tested at 73 degrees, but then depending on their final temperature rating, it could be 140 or 180. So when you're thinking about the types of systems you're installing, especially in commercial buildings or in places of the country where you know the water quality is not near a neutral pH, which a lot probably aren't, you need to be thinking about what types of piping materials you're using to ensure that you are providing a sustainable solution for your piping systems in that building. I listed SF 14 down there. That's simply a standard for plastic piping components. So within that standard, it encompasses minimum physical performance and health effect requirements. But really for health effects, it states that it just must comply with NSF 61. So I think the final takeaway from this is that we think water is a pretty benign inert substance, but it's not. It has different chemistries, and the chemistries are alive, and it's affected by things that are dissolved in it. And so we need to be aware of that and how it affects our health and how it affects our piping systems. So I'll review a little bit about LEED and LEED v4 in the building design and construction arena. A lot of what piping systems can get you as far as credits are within this materials and resource section. We didn't talk much about landfill diversion in this, but it is part of the LCAs for that end use phase, and it's an important part of LEED v4. So you look at the recyclability of your piping materials. This is really a big charge within LEED is recyclability, making sure that when you're demolishing buildings that you have some kind of waste management plan and that you're segregating materials, but then also during the construction phase that you have the ability to collect those recyclables and find an outlet for them. So I think a lot of people are familiar with metal recycling and its ability to be recycled. But when you're looking at non-metallic systems, you know, all thermoplastics are recyclable. So check with your local recyclers to see what kind of streams they'll take, and make sure you set up storage and separation for those materials, because it's not trivial, and it can really help in the long term, reduce the long-term impact of construction and that changeover in building stock that I talked about. You'll see the 2 heavy metal reduction credits. This is kind of a slam dunk for piping systems since we already have existing standards that help regulate that. So make sure that you're thinking about your piping systems when you're going through those credits. Transparency we harbored on quite a bit, and that's because I think it really is the future of sustainable building and sustainable products when we're talking about it. It's the next step in understanding better our impacts on humans and the environment and society. So I talked about a little bit about product disclosure and optimization. That has to do with the life cycle assessments and environmental product declarations. Environmental product declarations do give you a few more credits than an LCA, or partial credits than an LCA, simply because it's one step further. So the U.S. Green Building Council wants to encourage companies to go to that extra effort to acquire these EPDs to make it easier for the end user to eventually make comparisons. But both still will count toward that credit. You also see the sourcing of raw materials. That's another trend that's coming, and Terry alluded to a little bit, where we're not just looking at the immediate supplier, but we're going farther and farther up the supply chain to make sure that everyone within that chain is doing the best they can to keep sustainability in mind. And to put that into context, you know, for a company like Lubrizol, we have thousands of raw materials that we deal with that go into our products, and we would consider ourselves an intermediate product company. So we sell the material into piping systems, and then our suppliers themselves have hundreds of raw materials that might go into their products. So you can see how that tree just branches out and becomes very complex. So it's going to take time and a lot of effort to work our way through that. But the LCA process does capture a lot of that. Terry, did you want to add
Yeah, I mean,
on that?
the biggest challenge when we've done, for example, the corporate environmental footprint for the Lubrizol Corporation as a whole, and of course Lubrizol manufactures many more products than just CPVC pipe. Our principal products are engine oil additives. When you take the totality of the corporation and are attempting to identify what are the critical things that we had to work on or will be working on as a company, the simple fact of the matter is 80% of our footprint as a corporation is upstream. It comes from the materials that we purchase, and to Tom's point, that supply chain. And so grappling with the supply chain going forward is probably one of the biggest issues that all industries are going to face in attempting to achieve sustainable products.
Mm-hmm. Yeah, it's definitely a challenge going forward. Not insurmountable, but will take some resources. I also want to touch on some VOC reduction credits. This mostly, almost entirely applies to non-metallic pipe, such as ABS, PVC, and CPVC, when you're using solvent cements. But if you look in North America, those major solvent cement suppliers offer low VOC solvent cements, which conform to Air Emission Board standards. So keep those in mind when you're also looking for credits for LEED, because those do exist, and they're out there. And they've really done a lot to help with retrofits as well, with occupant health and safety. So I touched on a little bit about the pilot credits, and I summarized them down there. You have the integrative analysis of building materials. That was the matrix that I talked about. That's something, ask your product suppliers about it. Take it to them and say, could you fill this out for me, or do you have information that might apply to this credit? Just challenge them and see what you get out of it. Building material, human hazard, and exposure assessment. That one is in a little earlier stage than integrative analysis. We're working through exposure modeling and seeing what comes of that when a material supplier like Lubrizol provides their formulas, their recipes for exposure modeling, and what kind of outputs we get from that. So that's still in an earlier stage, but look for that to come. And then we talked about the supply chain optimization credit. So for my final slide, I wanted to give you just a few resources that I think are helpful. First of all, when you're looking for sustainability information, go to manufacturers' websites. A lot of companies now, they have a sustainability tab that's sitting there on their website, and a lot of times you'll find some really good information in there about their products, or you can find out ways to learn more about their products and their effects and impacts. Another great place to look is the UL Spot database, which is coming online and really growing. It's a nice database of building products, and they collect any kind of product certifications, LEED credits that are associated with the products. So you can go and you can search through categories and find products that will apply toward LEED, but also have other certifications within that database. And now it was just released, there's now a plugin for that into Revit. So you can access that database through Revit, which is becoming a very powerful tool. So while you're working in Autodesk and with your Revit files, it can pull in from that Spot database. And then finally, we talked a little bit about environmental product disclosures. To educate yourself a little bit more, if you're interested on how this is all coming together, there are two sites that I would recommend that I placed down there. The Program Operators website is a consortium of people like ASTM who are creating these product category rules, and as more get created, they update the site and explain those category rules and what the application is and what the functional unit is. And then they also have a catalog of existing EPDs and the product categories. One more resource that I wanted to mention that's not listed up here is it's a NIST database, NIST, but it's called BEES, Building for Environmental and Economic Sustainability. They've been doing life cycle assessment work for 20 years as a government organization, maybe more. This BEES database has been around for just about that long, but they just launched their latest version of it, and they're running a beta right now. It's much more user-friendly. But they are eventually working toward a tool for full building life cycle assessments. So you'll be able to go in and start selecting building types and locations and try to get a feel for the amount of energy it's going to take to build a building in that location, the amount of impact it'll have. They're really powerful tools, and I feel like they don't get enough spotlight, but they really are doing a lot of work in the realm of life cycle assessment. So that about wraps it up for me. Terry, did you have any other last comments?
I just one comment I neglected to make at the front end, that you may ask, well, what's the appropriate protocol for doing a life cycle assessment? There are ISO standards for doing product life cycle assessment that any of the responsible practitioners will follow. If you're looking for, you know, the best possible analysis, look for an ISO compliant peer-reviewed LCA. That will tell you that it's not only complied with the normal requirements, but has been reviewed by a independent third party for its rigor both in design and analysis.
Excellent.
We appreciate your time and hope you found today's webinar to be a valuable experience.